Hello everyone, welcome to our project presentation video. My name is Pujarani Maiti. Today, me and my group members will walk you through our KNIME Analytics project. We have built something called the Dark Store Inventory Intelligence System. Now, before we go through our technical details, let me first explain the real world business problem that we are solving. You all have used apps like Zepto, Blinkit, or Swiggy Instamart. These apps promise to deliver groceries to your doorsteps in just 10 minutes. But have you ever opened these apps and saw the words like out of stock or the item you wanted is not available right now? So you close the app and order from a competitor. That company lost a customer, maybe forever. This happens because these companies, called quick commerce companies, operate small warehouses inside cities called dark stores. And managing inventory in these dark stores is incredibly difficult. They have 2000 products in each store. They must decide how much of each product to keep every 4 to 6 hours. If they keep too little, a stock out happens. If they keep too much, the product expires and money is wasted. Our project solved this exact problem using data analysis and machine learning built entirely inside KNIME Analytics Platform. Let me now hand over this presentation to my teammate who will tell you about the data we used in this project.
Hello, my name is Nankumar Maji. Now I handle the data preparation part of this project. The first question of any data analytics project is where does the data came from? In our project we used real data set from Kaggle. The dataset contains over 3 million rows. There is 3 million transactions recorded over 4 years across 54 stores and 33 product categories. We downloaded 5 separated files, 10 CSV which had the main sales data, store CSV which had store location and types, holidays and events data, daily transaction codes and oil price data as an economy indicator. In KNIME, we loaded all 5 files using CSV reader nodes. We then connected statistics nodes to each file to understand the data. How many rows, what are the maximum and minimum values, and there are any missing values. We found that the oil price file had some missing values for some dates. We fixed this using a missing value node, replacing empty price with the average value. We also found that the data columns were loaded as text, not as actual data format. We fixed this using string to date and time nodes across all files. Finally, we used joiner nodes to merge all 5 files into one single master table. My teammate now explain how to create smart features from this data.
Thank you. My name is Demal Hajra and I worked on feature engineering and building the machine learning model. Raw data is not enough to build a good model. We need to create smart features, new columns that capture patterns and signals that the model can learn from. For example, raw data has a date column, but we extracted from that date the day of the week, month, the week number, and whether it is weekend or not. Why? Because sales on a Saturday are very different from sales on a Tuesday. We also created a moving average feature, the average sales of the last 7 days. This tells us the recent demand trend for each product. We created a lag column, the sales from the same day last week. This is powerful because grocery buying has a strong weekly pattern. We also created a spike flag. If sales on any days are greater than 500 units, we mark it as a demand spike. This helps the model identify unusual high demand events like festivals or match night. After feature engineering, we had 12 smart input features ready for modeling. Now for machine learning, we built 5 different models. Let me explain each one simply. First, linear regression. This is the most basic model. It tries to fit a straight line through the data to predict sales. Think of it as the foundation. Second, H2O gradient boosting machine. This is a powerful advanced model that builds hundreds of decision trees, one after another, each learning from the mistakes of the previous one. This was our best model. Third one is decision tree classifier. This model answer a yes or no question. Will there be a demand spike today? Like a flowchart that split data at each step. Fourth, logistic regression classifier. This model classifies each product at each store into 3 risk levels: high risk, medium risk, or low risk for stockout. Now the fifth one is KNIME clustering. This model grouped the 54 stores into 5 behavioral clusters based on how similar their sales and footfall patterns are. Now my teammates will share the result of these models.
Hello everyone, my name is Shayani Banerjee and I will share the results and key findings from our analysis. So let me start with the demand forecasting results. Our baseline model is linear regression, which gave us an R-square value of 0.53. In simple words, this means the model could explain 53% of variation in sales. The error was about 85 units per prediction. But when we used the H2O gradient boosting model, the R-square improved to 0.721. That means the model now explains 72% of sales variation. The error dropped to 654 units, which is 23% improvement over the baseline. This tells us that the gradient boosting model is significantly better at capturing the complex patterns in grocery demand. This became our full and final prediction model. Now, for stockout risk classification, we used logistic regression. Overall accuracy was 94.3%. More importantly, for high-risk items, the items mostly likely to stock out, our model achieved a recall of 99.6%. This means the model almost never misses a truly at-risk item. In business terms, this is extremely valuable because missing a high-risk shortcut is very costly for the company. For spike detection, we used decision tree. We achieved 99.99% accuracy. The model is correctly identified 83,030 demand spike. Events in the test data, near perfect performance. For store clustering, we used K-means. We found 5 distinct store types. When we plotted the scattered chart, we could clearly see that the stores with higher footfall also have higher average sales, which confirms our business hypothesis. To summarize our model results in one line, our best model predicts demand with 72% accuracy. It identifies stockout risk with 94% accuracy and detects demand spikes with 99% accuracy. So now let me hand over this project to my teammate who will explain the final outcome of this project.
Thank you. My name is Swam Kumar. I will explain the final output of our system, what it looks like and why it matters for a real business. All our prediction models flow into what we call the replacement engine. This is the brain of our system. This engine takes a demand prediction, add a 20% safety buffer and automatically generates a replacement order for every stores and every product. It can be classified each product order as a high priority, medium priority and low priority. The final output is an Excel file called replenishment report that any operations manager can open and immediately understand. No technical knowledge is required to read that report. Our pivot table summary shows 108,000 store product combinations are classified as a high priority, meaning they need to be restocked immediately. The total reorder quantity across all stores is 12.4 core units. The bar chart we build in a KNIME visually shows that high priority items have the largest reorder quantity, gives the manager instantly visual clarity on what we act first. So, what is the real business impact on the system? If a quick commerce company deploys our system, we estimate stock out events can be reduced by 35 to 40%. Perishable waste can be reduced by 20 to 25%, and customer satisfaction improves because items are always available when they order. In conclusion, this project demonstrates the KNIME Analytics Platform can be used to build a complete end-to-end data analytics solution from raw files, CSV files, all the way to automated business decisions without writing a single line of transitional codes. We hope this video gives a clear understanding of our project. This was built as a part of our MBA Business Analytics coursework at Raiganj University, ILM Kolkata. If you found this useful, please like the video and leave a comment below with any questions. Thank you.